Greetings, and thank you for joining us for another SANS ICS concept overview. I'm Don C. Weber of Cutaway Security and a certified SANS instructor. In the Modbus enumeration concept video, we discuss using Modbus to communicate to a simulated program logic controller. In this video, we will capture Modbus traffic going to a Schneider Electric M221 PLC. This PLC was provided to me as a part of the ICS Village Community Engagement Project, and I'll include a link to that project in the show notes. If you enjoy this video and the topics we cover in the SANS ICS concept overviews, be sure to like and subscribe to this channel. Leave a comment if you have a question about this topic or suggestions for future content. For this concept overview, we're going to be using the SANS ICS 410 Control Things Linux virtual machine to analyze Modbus traffic to a Schneider Electric M221 program logic controller, or PLC. We're going to provide several examples of how to quickly locate the Modbus communications, understand the Modbus interactions, and identify suspicious activity. But before we get started with our analysis, what I want to do is I would like to demonstrate how we captured this traffic in our lab.
This network capture is going to be done using a Schneider Electric M221 program logic controller. We're simulating that this program logic controller is connected to two pumps, a primary and a secondary pump, and we're going to be controlling those pumps using Modbus. So we'll read the state by doing Modbus reads, and we'll change the state of those pumps, turning them on and off with Modbus writes. The PLC is connected to our network infrastructure via that black Ethernet cable. As we can see, we have a network switch on the right hand side that's connected to two other devices. The gray Ethernet cable is just a spam port that we're going to use to sniff all the traffic across all of those ports. Here we have an engineer laptop it is running an HMI and also the Schneider Electric management software, which is the EcoStruxure Machine Expert Basic. Over here we just have another system that's on the network. It could be a rogue device, it could be an HMI. This one is obviously running Linux. We have our sniffing software. We're going to go ahead and start that right now. We're going to start sniffing the network on the spam port. Over here on our engineer laptop, we can interact with the pumps by turning them on and off. So the primary pump is off, the secondary pump is on. We'll turn the secondary off and the primary on. We're also going to log in with the SE management software. So this is going to generate different traffic that should be over the Modbus protocol. Over here on our rogue device, we're going to leverage the Modbus client to do Modbus commands and do read coils on the pump. And we'll see as actions are changing on the pump that those values change. We're just using the polling feature of Modbus client to continuously ask the PLC what the state of the pumps are.
Okay, now that we've captured our traffic, what I've done is I've actually transferred it over. I could have used the Control Things VM to capture that traffic if I wanted to, but I transferred it over from my lab system to here, and as we can see, we've got this on our system. And I can just double click on that, and that's going to automatically open it up in Wireshark. And like most people, I start scrolling through trying to look at the different traffic. If this was an actual production network, we'd see a lot more than Modbus and TCP on this within this capture. And so it would actually get rather confusing because we're going to see a lot of Windows traffic. We're going to see a lot of other industrial protocol traffics in there. It's going to get all mixed up. And so one of the first things that I like to do is I like to go to this statistics tool and look at my protocol hierarchy. And what this does is this gives me a breakdown of all the different protocols that are within this network packet capture. And as we can see, we do have some Windows traffic that was captured in here. We're not really going to be worried about that. And so we do see the Modbus TCP in here. So definitely we have a capture that we've validated that we have a capture with some of the communications that we expect to see on here. We can actually go even further using this, and by clicking on the endpoints. If we click on the endpoints and use this, what Wireshark will do is it will provide us information about all of the different systems that we're communicating on this network. And as we can see here, we've got several IP addresses, broadcast IP addresses as well that we're communicating. But we can go even further with that. We can do a display filter. So if I go to this where it says apply a display filter and I just start typing Modbus and I can autocomplete, and I still have to hit enter after that, this is going to isolate all of the Modbus traffic that is within this capture. And I can go back to my statistics and click on endpoints again. It comes up, analyzes it, shows me all the information about the systems that are on here, but I can come down here to the bottom and I can check this box, limit to display filter. And what this does is it takes my Modbus display filter and applies it to all of these systems. And I can see here that I've got 3 systems that are doing Modbus communications. My PLC is the .21 address. My engineer workstation or laptop is .53. But then I have this other one, this 100. Now I might expect that those communications, that might be another system, an HMI or something that's on our network. But potentially this could be a rogue device as well. Or it could be a system that I expect, but not expect Modbus to be coming from this system. So this is one way to quickly identify if we have suspicious activity on our network. So I'm going to go ahead and close that. Now we're filtering on Modbus, that's fine. I'm going to keep that filter. And what we're going to do next is that I'm going to modify Wireshark slightly because I do like to include a little bit more information in this upper window right here. And as we can see, we've got some fields. The dissector, the middle window is our dissector. The bottom window is providing the raw bytes. And if I expand the different fields, I can expand the TCP field. And if I right click on the source port, I can apply as a column. And what this will do is it will update and add our source ports here to our column. I actually like to go a bit further. We can see this in our analysis. This is the field that it is filtering on is tcp.sourceport. I also like to add UDP source port, and we can click here. I like to add that on there just because when I have UDP traffic, I want that information displayed as well. And I'm going to change the title, click OK, and now we can see that that's added. I also like to add my destination port, so let's add that as a column. Move it over. Let's edit the column and change our name. Let's add UDP in here. All right, now I'm good to go. Now this helps me understand the direction of the packets because the communications to the PLC should be going to port 502 because our destination port will be 502. So I know this traffic, this packet, which is a query to the PLC, is going to the PLC. And you'll see how that's important when we start thinking about using other analysis tools like Tshark that we'll do in just a minute. Okay. So now what we've done is we can isolate, we've made it a little bit easier to understand the direction of the flow of traffic. But Wireshark provides us with some other capabilities. Wireshark automatically dissects not only the Ethernet and the TCP portions of the packet, but it also understands Modbus. And as we can see here, I've expanded the Modbus TCP header, and then also the Modbus data. Okay, in the Modbus TCP header, we can see it, has a transaction identifier, protocol identifier, unit identifier, things that we would expect in the Modbus TCP header. You can go back out to the Wikipedia page. When we talked about Modbus enumeration, we briefly touched on some of the breakdown of the protocol, but you can definitely look to the wiki page and it'll provide you with more information about that. One of the things that we're concerned about are the function codes, because the function codes help us understand what the communication actually is. In this case, it's a read coil. And what I like to do here is I do like to apply, I'm trying to locate suspicious activity or activity that is, I would expect if I was looking for some types of traffic, I'd want to know whether or not there's writes going on. So reading from a PLC is fine. That's just giving information to somebody. But writing to a PLC, that would be making modifications to that endpoint, also to the process. So what I'm going to do is I'm going to right click on this field, and I like to prepare as a filter. You can apply a filter, but I like to prepare a filter because usually what I'm going to do is edit it. So I'm going to click on selected, and as you can see here up in my display filter, that has changed. It's moved from Modbus to Modbus function code equals 1. And if I just hit enter on that, all of the communications that here are being displayed to me are going to be everything that's associated with a read coil with function code 1. But as I mentioned, I want to see everything that's a write. And if we look at our function codes for Modbus, we'll see that anything that's greater than a 4, so 5, 6, 15, 16, those are going to be associated with write commands. So if I would just want to display all of those function codes or all of those Modbus writes, then I would just hit use this display filter. And as you can see, my packet has changed. And now I see all of the writes. And I also can see now the destination, the query, where they're coming from, the source IP address, the destination IP address. And it's quickly helped me identify specific communications within this network traffic. And I can just scroll through and now review this if I wanted to. Here, I can use my display filter to filter out even more if I've got some specific things that I'm looking for. Okay. There's something else that's interesting in this traffic, and I understand it, and we talked about the Schneider in the capture. We talked about the Schneider Electric management software that's communicating with this PLC, and that is actually leveraging a proprietary form of Modbus. And we can see that here if we filter on Modbus function code 90. Okay, and it is still, Wireshark is still parsing it as Modbus, but the reason why we know it's proprietary is because it does not provide any additional information beyond the function code. Okay, so if we went down to all of the queries and even the responses, we can see that we have a function code of 90, but then we just have data. Okay. One of the ways to analyze this, so we can certainly go through each packet, but one of the ways that I like to help display this to me a little bit better is to make this Modbus data just a column. So what I'm going to do is I'm going to right-click on the data, and then I'm going to apply as a column. And you see up here that it's added this information as a column, and now I can see all of the data that's being passed to function code 90 displayed, and I can click through here and identify something that I want to analyze a little bit more closely. I can actually export this information if I right click and follow TCP stream. I'll get a display of all of the Modbus data that's in there. Right now it's being displayed in ASCII, but I can change that to raw. And we can see that we have the exchanges, queries and responses. And this is displaying not only the Modbus data, but also it's actually displaying the TCP data. And we can see here that our this data should be right in this area right here. So that would be our Modbus data. Okay, just an example of different ways that you can analyze this information. Now, while Wireshark is extremely valuable for starting our analysis, I like to speed things up. And to do that, I like to use scripts. I like to use commands that have helped me identify certain things in the past. That way I can, instead of going and doing this analysis by hand, I can quickly pull out information that is valuable to me for either my security assessments or doing incident response. And so what I've done is I've come up with a couple commands that will leverage Tshark, which is a tool that's provided by Wireshark, and this will help me analyze our packet capture more quickly. So just an example, if we want to use Tshark to read a file, we just type the command Tshark in our command prompt, give the option-R and our file name. So let's switch over to our terminal. We can see that I'm in a folder that has our packet capture in there. I will paste our command Tshark read from our packet capture, and we'll just hit enter. And what this is going to do is this is going to display all of the information from our packets, but it's just showing me that it sees Modbus. Now I know that I see Modbus. This command actually read every one of the packets, so it's displaying information about the packets. So that's not really necessarily that useful to me. I might use that to validate that I see a certain protocol in there, but what I like to do is I like to drill into the specific fields. And as we can see here in this command that I've pre-built for this, okay, we have the Tshark command and then we have the read from packet. But what I'm going to do is I'm going to use a feature within Tshark, the option for fields, and I'm going to display some very specific fields. I'm going to select the frame number, I'm going to select the IP source, the TCP destination port so I know which direction the communication is going to go in, function code, and Modbus data. And this is going to give me some information that I can quickly analyze. And what I'm going to do is I'm going to build all of those fields and I'm going to separate them using a comma. So let's go ahead and copy this. Actually, one of the questions might be like, how do I understand what these fields are? I demonstrated that before. So if I wanted to understand what the function code field was, I'd just come over, I'd click on that field in Wireshark, prepare as a filter. I use prepare so it doesn't modify what I'm actually reviewing right now, and then I just do selected. And so I can take the Modbus code, and I'm just going to take the name of the field from this, copy it, and then paste it into my terminal. But right now what I want to do is I want to take this Tshark, I want to copy this, paste that command in, and now it's going to run this command and it should separate out all of the fields from my PCAP, and we can see that it did. Okay, so we have our frame number, which is basically our packet number, so that we can reference back to it if we wanted to do some additional analysis specifically in Wireshark, review that packet. We see our source IP address, the destination, and then the function code. And if there's a function code that, if we have Modbus data that couldn't be analyzed by Wireshark, parsed by Tshark in this case, then that is displayed as well. So we see all of our Schneider Electric proprietary Modbus communication packets information in here as well. Now I can take that, and instead of outputting it to a screen, what I can do is I can redirect this into a file. So, and we'll give it the extension CSV, and so I'm running the exact same command, and this is going to produce a CSV file that we can open up using a spreadsheet program. So let's find that file here. We can see the CSV. I'm just going to go ahead and double click on that. And on control things, we have the LibreOffice. This is going to recognize it as a CSV file, and we can set our delimiters, comma delimiters. One of the things I like to do, and this is kind of important because of the way it displays the information, I want to go ahead and change each one of these fields from standard to text because this tool, LibreOffice, might modify some of those values. The display might not include some of the leading zeros in some of our data. So I go ahead and change that just so that it's displayed properly to me. And as we can see, now we have a spreadsheet with all the information that we had before. We can add a header line if we wanted to. These are our frame numbers, our source IP addresses, our TCP destination ports, function code, and data. And we can scroll down here and quickly identify writes, the directions where it came from, understand whether or not our rogue devices, let's see, there should be a 100s. We can see whether or not they have done any writes to our PLC. Okay, and we have this information. We can pull that in. We can filter out things like the Schneider Electric management stuff we may or may not be interested in. Now, I just mentioned that we want to know what the rogue device was, whether it was doing writes to our PLC. So let's go ahead. We've identified that our IP address for our rogue device is at .100. So let's go ahead and create a filter for that. So I'm going to right click on source. I'm going to prepare a filter because I'm going to modify that slightly. I'm going to say 100, but I don't want it just to be the source. So any communications with address 100, I want to display there. Okay. Now I can also, so this is all of the communications. I've filtered on all those communications to our rogue device, but I also want to filter on whether or not we have a Modbus write. So let me collapse this. So here we have our function code. I'll right click on the function code, prepare filter, and selected. And this will update my display. I want to go ahead and modify this slightly. Writes are going to be anything that's over function code 4. I'll hit enter, and as we can see, the Modbus communications from this rogue device did not do any writes to the PLC. That may or may not be, this is just suspicious activity still at this point. I'd want to do some further investigations, probably go find out what that device is, whether or not it should be doing these communications or not. So in this concept overview, we discuss analyzing Modbus network traffic to a program logic controller. We use Wireshark and Tshark to understand these communications and speed up future analysis efforts. Thank you for tuning in to another concept overview with the SANS ICS and Cutaway security teams. Please let us know if there are other topics you would like us to cover in the comments below. If you enjoyed the content, please be sure to like and subscribe to the SANS ICS YouTube channel. This has been Don C. Weber of Cutaway Security. Go forth and do good things.